the hard-to-Fock, the phi would be minimal basis set. That's the Slater determinant with both electrons in the sigma g orbital. And one with alpha and one with beta spin. And remember, if I write it out, I get the diagonal minus the off diagonal. So, and I get a 1 over square root 2, I guess. 1 over square root 2, that's the norm of the Slater determinant. And then I get sigma g. And can we, better write the electron sigma g1. And I don't want to write the spin function explicit next to it, so let's just do spin orbitals. So let's say this is alpha, sigma g alpha for electron 1, and then electron 2 has to be sigma g beta. That was the diagonal. Now I have to do the permutation, so I get sigma g beta for electron 1 and sigma g alpha for electron 2. Sorry. Then let's look at the double excited determinant. Epsilon. That's 1 over square root 2. Double excited means both are now in the sigma u, but otherwise it's the same. So it's sigma u alpha 8, sigma u beta 2, minus sigma u beta 1, and sigma u alpha of 2. Right, now what want I do? I want to do this one. So I have phi, and I have a sum over I larger than j, but I only have 2 electrons. So I just have G12, and then I have this, why can't I write a big D? Like this. Now let's insert that. 1 over square root 2, 1 over square root 2, 1/2. Big parenthesis. So I'm going to have one integral where I have sigma g alpha, sigma g beta, G12, that's this one. And on the right hand side, also take the first one. Sigma u alpha, sigma u beta. That was the first integral. Now let's take this with that. And there's a minus sign. Minus sigma g alpha, sigma g beta, G12, sigma u beta, sigma u alpha. Right? I keep on writing. Sigma g beta, that's this one now. The second one up here. Sigma g alpha, G12, and I take the first one, that should be sigma u alpha, sigma u beta. And the last one, can I squeeze that in here, is then sigma g beta, sigma g alpha, G12, and now the second one, which is sigma u beta, sigma u alpha. Thanks. Okay. Let's look at this one first. I have to integrate over 4 coordinates, 3 spatial coordinates and the spin coordinate. Let's look at the spin coordinate first. Electron 1 has alpha spin because if I do that, I can split that up now in a spatial integral and a spin integral. So I have sigma g, G12, sigma u. That's the spatial integral. And then I get a spin integral, which is alpha, beta, beta, alpha. this is 0. Because I have alpha spin for electron 1, because that I can again split it up. There's no operator, so I can split it up into two integrals. Alpha, beta, so now I have to write electron 1 times beta electron 2, alpha electron 2. So I have two integrals, one for electron 1, one for electron 2, and the product of them, but those two spin functions are 0. This is 0, the whole thing is 0. Same holds here, beta with alpha, alpha with beta, bye-bye. Now I'm only left with those two, and I need another blackboard. By the way, and I'm going to cut that out later on, in the other room, that's not a blackboard, but it's a green board. So every time I try to add it or load that up and to add that video, it tells me that it has a green background. But I want to remove the background so I can better put it on top of another video. And one day I'm going to try that. What happens if I do that? Then I can put some other background in. Write on some, I don't know, ice cream or whatever. Make you really distracted from the equations. I'll make a special version. Good, back to my integrals. Back to the integrals. 1/2 parenthesis. And I mean, I can do the spin integration, I guess, in both integrals also. This is alpha with alpha, beta with beta. The spin functions are not only orthogonal, if they are two different, but they are also normalized. So this gives me 1. Same here, gives me also 1. So I should just get sigma g, g1, 2, sigma u. And then what do I get over there? I get the same. Plus sigma g, g1, 2, sigma u, sigma u. And going 2 steps back, I think they look very much the same, those two integrals, don't they? So I get one integral, sigma g, g1, 2, sigma u. And I'm done.